Hello guys, welcome everyone to today's stream. Today we are gonna discuss and solve Leetcode Biweekly Contest 153. It's a live after a very long time. I welcome everyone to today's live stream. How are you doing guys? I felt that today's contest was pretty much difficult compared to our last few contests. Even the leaderboard and the ChatGPT coders are facing a lot of difficulties. We can clearly see its impact in our final board. So, we'll go to our first question of the day. The first question is reverse degree of a string. Wait a second, guys. Okay. Chalo, guys. So we'll go to our first question. Reverse degree of a string. Given a string S, calculate its reverse degree. The reverse degree is calculated as follows. For each character, multiply its position in the reverse alphabet. A is equal to 26, B is equal to 25, Z is equal to 1. It's just reversing the index of alphabets where A will be 26 instead of 1 and Z will be 1 instead of 26 with its position in the string 1 indexed. So the first number will be 1 here, indexed with 1. Now sum these products for all characters in the string, then return the reverse degree of S. We have to first multiply its position of reverse alphabet with the position, then sum the products and then reverse the degree of S. So we'll see this example. S is equal to ABC. Output we have got 148. How? Letter A reversed in alphabetical order, index in string is 1 and product is 26. 26 into 1, 26. B indexed in reverse alphabet it's 25 and index in string is 2 and product is 50. Same goes for 24. 24 C's index is 24 in reversed alphabet, then we have to multiply it with 3, its position in the index, and the product is 72. So the reverse degree of this is 26 plus 50 plus 26, which is 148. We'll see an example. Okay, what is the question name first? Reversed degree. For this question, what are we gonna do? What they are given? First, A to Z in reverse order. So it will be 26 to 1. Okay. Now multiply it with index. Multiply this with index. Index in string. And then finally sum of all. Sum all. Sum all the products. So this is what we have to do. I'll just give a small example for this. Chat, give me any one small uh, 3-digit word or a 4-digit word so that it will be simple to explain. So chat, anyone in the chat, just give me a 3 or 4 letter word. So I'm gonna consider, since there are no replies in the chat, I'm gonna consider Geeks for Geeks, which is GFG for now. If anyone, anything, just they can just type in the chat. I'll do it for them. Now, any replies in the chat, or should I consider my own example? So guys, I'll take a string s is equal to GFG. Okay. Now I took the string, the reverse index of G. What is the okay? First G F G. Now the reverse index value of G is 20. Its position is 1, and for F it's 21, and its position is 2, and for the third G it's 20, and the position is 3. So it's gonna be 20, 42, and 60, and the sum of it is gonna be 122. This is exactly how we are gonna calculate the reverse degree of the given number. So here we are multiply. For GFG it's 122, and then finally this is the sum, or this is what is basically our output. So now we'll go to our how to solve this question. We'll go to the intuition. Intuition. We have to calculate reverse degree calculate reverse degree for string. So what it is done, I already said A is equal to 26, B is equal to 25, somewhere some other digit will take X is equal to 24, like this it continues, Y is equal to 25, Z is equal to 20, sorry guys, B is equal to 25, X is equal to 3, Y is equal to 2, and Z is equal to 1. Also they are given that the string is indexed from 1, not from 0. So there won't be any 0 multiplication. Sure. Now, after this what we have to do? Second one, product with its index, with index, which is 1 indexed, not 0 indexed. Very important point to remember. And finally, the third one is sum. So what is the approach we are going to use for this? It's very simple. The first one is, anyone in the chat, what is the approach we can use to solve this question? Okay. So the approach is, first what we'll do, initialize some variable. Initialize some variable which is q to store cumulative sum. To store cumulative sum. It's getting too thicker, I'll change it. Okay, the second step is, we'll have to iterate the string. Iterate the one indexed string. Okay, we have to iterate the one indexed string. For this, what we'll do, for each character, we'll use this formula, simple formula for each character. For each character, what are we gonna do? We'll write this formula, reversed value is equal to 26 minus ASCII of ASCII value of character minus ASCII value of A. So guys, in this, what we have used is ASCII formula. In this, where ASCII of CH minus ASCII of A returns as the value, like for example, in the ordered way. Like the first one, ASCII of CH, will give us ordered way of ASCII, and the second one will give us the ASCII value of A, which is 97. So what happens now? With this, what is gonna happen is, we'll take, for A we'll take Example for A, 26 minus ASCII value of character, which is 97, minus 97. 26 minus bracket 97 minus 97, which will give us 0, and this 26 will be like this, which is equal to 26. So the reversed value of A is 26. Just give me a second, guys. Yeah, it's fine. Now if we check the same for B, 26 minus is the character value of ASCII value of B. It is 98 minus 97, which is equal to 26 minus 1, which is equal to 25. So the reverse value of 26 is 25. This is exactly how we have to do. And in our next step, what we'll be doing is, in the fourth step of our approach, add the result, add result to sum and return the sum, and return sum. So this is all basically. Now I'll just directly jump to the solution of this. Okay, so I'll move to the solution now directly. Here is our solution. We'll add commands for better understanding. Class solution, which is given already. Reverse degree, the attributes which are also given. Now Q is equal to 0, which is the accumulator of sum, or like cumulative sum. Cumulative sum or accumulator of sum. Next, R is equal to 1, which is position index. Position index, which is 1 indexed. Again, very important point, 1 index. Now for I in P, which is the for loop we'll use, this T is equal to 26 minus order of I minus order of A, which is basically exactly what I told, ASCII of I minus ASCII of A. So this is used to get reverse position, and then this is to get product, and finally this is for incrementing, increment position, and finally return Q. Q will be our final sum. So I'll just write this as sum here, simply confusion, I'll clear everything. So I'll be returning, very simple question, I'll run the code, we'll check if it works. Okay, so for the given test cases it works. ABC 148, test case to Zaza 160. I'm submitting it. Okay, so basically this works perfectly well and it's accepted. Now we'll go to the time complexity of this code. Time and space complexity. First, time complexity. The time complexity of this is, we are iterating through the string once, iterate through string once. So it's gonna be O of dash. Chat, what is the answer for time complexity? And the same for space complexity now. Anyone in the chat, what is the time complexity? So, and space complexity, there are some variables like Q, R, T. That's all, which is gonna take space of O of dash again. Chat, Phil, what is the space complexity and the time complexity of the code? Anyone in the chat? Very easy question. What is the time complexity and the space complexity? Come on, chat. What is the answer for it? Anyone in the chat, what is the time complexity? We are iterating once through the string and there are only few variables for space complexity, Q, R and T. So someone in the chat, pro coder, yeah, you are correct. The time complexity is O of n and the space complexity is O of 1. It's, I guess it's all clear, guys. Anyone, any doubts in the chat? Anyone in the chat, any questions? Okay, guys. We'll move to our next question. So, we'll move to our second question. First question is done. The second question is maximize active section in trade. First part of the question. The easy version basically. Maximize active section with trade 1. You are given with a binary string s of length n where 1 represents an active section, 0 represents an inactive section. You can perform at most one trade to maximize the number of active sections in S. In a trade, you convert a contiguous block of ones that is surrounded by 0 to all zeros. Afterwards, convert a contiguous block of zeros that is surrounded by ones to all ones. Return the maximum number of active sections in S after making the optimal trade. Note, treat S as if it is augmented with a of 1 at both ends, forming T is equal to 1 plus S plus 1. The augmented ones do not contribute to the final count. So the example S is equal to 0, 1. S is equal to 0, 1. The output is 1 because there is no block of 1 surrounded by 0. So no valid trade is gonna be possible. So, and now we'll go to the next question. Next example, input as 0, 1, 0, 0. So what we'll do now? We'll augment the string to sorry guys. They have given us to augment the string. How are we gonna augment? T is equal to 1 plus s plus 1. So string, first we'll add 1 plus string plus 1. So now what will happen? I'll go. So the name of the question is maximize active section with thread. Maximize active section with thread 1. This is the second question of today. So what is the example they have given? 0, 1. Okay, before that, how can we augment it? We have to add is equal to t is equal to 1 plus string plus 1. Is that what they have given there? Yeah. 1 plus s plus 1. This does not count for the final though. So final only it will be s. Now, what was the given example? The example we took is 0, 1, 0, 0. So now, am I correct? Was this the example which we took, guys? Yeah, 0, 1, 0, 0. Now once I augment it, it's gonna be 1, 0, 1 plus 0, 1, 0, 0 plus 1, which is gonna give me 1, 0, 1, 0, 0, 1. So you can check here 1, 0, 1, 0, 0, 1. Now what I'll do, I'll choose this 0, 1, 0, 0. I'm gonna choose the 0, 1, 0, 0 here. Choose 0, 1, 0, 0. And then what should we do? We have to convert this 1, 0, 0, 0. So once I convert, what is this gonna be? It's gonna be 1, 0, 1, 0, 0, 1. This is my string. Now I convert this. It's gonna be 1, 0, 0, 0, 0 and 1. Now after this again converted, it will be 1, 1, 1, 1, 1, 1. So now we have to remove the string which was augmented. So now our final value here is till now 1, 1, 1, 1, 1, 1. Now we have to remove the augmented values from here. I'll cancel the first and the last added values, the augmented values. So it's gonna be 4. So the final string is 1, 1, 1, 1. With this, I'm gonna get the output as 4. So the maximum number of active sections here are 4. Max active sections. Max active sections. So many people would have thought this is already a sliding window question. Yes, this can be solved using sliding window. But we are gonna use, okay, I'm sorry guys. There was a small disconnect. So for this question, we are gonna use greedy with two pointer block. Before that, we'll go to the intuition. What is our intuition? Intuition, guys. So the intuition is we have to maximize the active sections. Max active sections. Maximize the active sections. For this, what we have to do? Convert convert contiguous blocks of ones surrounded by zeros to zeros, and blocks of zeros. This is first one, and now the second one. Ones, sorry, this is now zeros zeros surrounded by ones to ones. That's basically all what we are gonna do. Since the string will be augmented, that is t is equal to 1 plus s plus 1. 1 is a string index, like string we are adding here. We have to ensure that the string is enclosed properly within the active sections. So to achieve this, we have to find the largest combination of of two adjacent groups. We have to find the largest combination of two adjacent groups, two adjacent zero groups. So, and then trade them for equivalent or larger section. And after this, trade for equivalent or larger active section. Now we'll go to the approach, guys. Approach. Approach. First one. Okay, wait. I'm gonna start from the corner. The first step, initialization. Initialization here, what we'll do? Maintain count of okay, I'm not gonna write everything. We are gonna maintain a count of active sections active sections that is number of one groups in the string, that is number of one groups in string. Okay, after this what I'm gonna do is track current block of track current block of zeros. Next, after this what I'll do, I'll track previous block of zeros. This is CUR0, this is PREV0. So after this, finally we are gonna track best trade option for us. Best trade. Now, this is our first step basically. So, we'll go to our next step. Our second step, iterate through the string. Iterate through string. For this, what I'm gonna do is, if character 0, if character is 0, I'll increment CUR0, increment CUR0, I'll write as CUR0 plus plus. The size of the current 0 block will be added. If character is 1, if character 1, what I'm gonna do is count an active section. Count active section. Act section, which is basically result is equal to result plus 1, result plus equal to 1, whatever, both are same. And then what I'll do is, this is step number 1, the step number 2, if previous block is 0, if previous block is 0, what I'm gonna do, if previous block is 0, then I'll check if merging will give better result. Merge gives better result. And then finally what I'll do is update my prev0 to current 0 and reset current 0. Finally, in my third step, what I'll do is, in my third step, I'll compute the result. COM compute the result. For this, what I'll do, total sections. after optimal trade, total sections after optimal trade is gonna be result plus trade minus 1. What is this minus 1? This minus 1 here, this is for losing existing section during trade. Losing existing section during trade. During trade. So that's our basically that's the approach we are going to follow. Now I'm going to show you the code and we are going to add our commands for better understanding. Now the first one, result is equal to 0, count active sections. Just a second guys, I'm going to increase the size of my browser's screen. And the previous 0, count active section is result, and previous 0 as I already told, size of previous, prev 0 block size, and the next one is current 0 block size, and trade is equal to 0, which is maximum improvement from single trade, max improve from single trade. Now the first one, iterating the for loop, iterate over augmented string. This is basically augmentation. The first case, if C is equal to 0, what we have to do? We have to expand our current block. So expand current 0 block. After this, what I'll do is, next, if not, count one section. Count one section. Now, if our previous trade, PRV 0, previous trade is 0, and also current trade is also 0, now we are gonna check if best trade option, best trade opportunity, or I'll just write it as option. Now we have to give the value of CUR 0 to previous of 0. This is update prev 0, then reset current 0. Finally, our result or so called max active area, max active section. Now I'm gonna run this code first. We'll check if it works. Yeah, it works well for the given test cases. Now I'm submitting it. Okay, it works well and it's one of the most optimized codes. The first question was also optimized. This is also the most optimized code. Now I'm going back to the question. We are left with the last part of this question, the time complexity of this question. It's gonna be O of n iterating to iterate string once. So basic. Now the space complexity is gonna be O of 1, few integer variables used, few integer variables are used, and they are independent of size. With this, we are going to end our second question, and we're going to jump into our third question. Chat, any doubts for anyone? Please ask in the chat section. If any doubts, please ask in the chat section, guys. So there's a good number here. Leetcode reaches 3500. Well, now we are going to solve our third question of the day. Minimum cost to divide array into subarrays. Again, you are given the two integer arrays, nums and cost, of the same size, and sorry guys, just a second. Yeah, you are given with two integer arrays, nums and cost, of the same size and an integer k. You can divide nums into subarrays. The cost of ith subarray consisting of elements nums L to R is nums0 plus nums1 continues to nums of R plus k into I plus cost of L plus cost of L plus 1 till cost of R. Note that I represent the order of subarray, 1 for first subarray and 2 for second subarray. It's not the positions, it's the order of subarray. So it starts with 1, again 1 index, not 0 indexing. Just for this part. Now we have to return the minimum total cost possible from any valid division. And we know what subarray is. It's a contiguous non-empty sequence of elements within an array. So we'll see one example here. We have a question, nums is equal to 314, cost 466, k is equal to 1. Now, minimum total cost possible can be achieved by dividing nums into subarrays 3, 1 and 4. The cost of first subarray is 3 plus 1 plus 1 into 1 into 4 divided by 6, which is equal to 50. Sorry guys, 3 plus 1 into 1 into 4 plus 6, which is equal to 50. And in the second subarray, it is 4, 3 plus 1 plus 4 plus 1 into 2 into 6, which is 60. Now, we have to return the cost basically. Third question, minimum cost to divide subarrays. Thank you guys, everyone in the chat. Mithun, thank you. Now, minimum cost to divide array into subarray. A third question, min cost to divide array into subarray. Now, what we are going to do now is, we'll first see the intuition for this question. Intuition is first we'll go to the intuition. Intuition. Now, dividing the nums array into subarrays. Just a second, guys. We have to divide the nums array into subarrays. Nums array to subarrays. For this, what we are gonna do, guys? Anyone in the chat? And we have, this should ensure that it's done with minimum cost. Minimum cost. Minimum cost. So the cost depends upon so what does the cost depend on, guys? Cost of subarray. Cost of, what does it depend upon? Anyone in the chat, guys? What does the cost of subarray depend on? So the cost depends upon the first one, sum of elements, sum of its elements. Second one is order of subarray. And finally, the sum of corresponding cost values. Corresponding cost values. So we'll just write a formula for this. We are going to derive a formula for this. For subarray, for subarray, which is, okay, I'm sorry, the name of our subarray is nums L2R. The subarray R. What will be the cost? I'm gonna write the formula. Cost is equal to summation of nums 0 to R plus k into I into just a second, guys. Just a second, guys. This is a technical error. Yeah, it's done. So the formula is summation of nums 0 to r plus k into I into summation of cost L to I, sorry, L to T. Our goal is to, our main goal is to split numbers, the nums array optimally to minimize cost, to minimize done. So with this we are going to go to our approach. So what is the approach to solve this question? Approach. First one, prefix sum calculation. For this what I'll do is compute, just a second guys, this is looking too much thick, the letters. Yep. Compute sorry, compute the prefix sum, compute the prefix compute the prefix sum of nums in partials so that the sum of any subarray will be calculated in O of one time. Sum of any subarray will be calculated in O of one time complexity. Now what I'll use is, in my second step, partials of I. Partials of I gives me sum of elements from nums 0 to nums I minus 1. Now, this is our first step. Second step is my favorite data structures. In our second step, we are going to use the DP which is memo as DP here. Now, first what I will do, use DP array where DP of I represents min cost of dividing the array starting from index I. Start with starting from index I. So in the next step, what I'll do, iterate backward, which is right to left. Iterate backward, right to left to calculate min cost. To calc calculate min cost for each index. For each index. Now, what I'll do is finally, after this, not finally, after this, what I'll do is for each I, I'll iterate over all possible sums, all possible endpoints, endpoints j to form subarrays. With this, next we'll go to, after this, we are gonna compute total cost. I gave the formula already, which is subarray cost is equal to sum of elements, plus k into subarray order into sum of corresponding cost, sum of corresponding cost. Now, after this, what I will do in my third step, I'll write the final result. There's not third step, there's a second step I'll consider to be. Let me write it within dp itself. Final result, which will be stored in dp0. dp of 0, which is the min cost for array, for entire array. For the entire array. Now, once this is done, we'll go to our code, guys. We'll quickly go to our code. Here is our code. I'm gonna increase the size of the browsers, this one, so it's visible. Okay, no need of this much. Let it be here. So yeah, class solution given, all the other function is given, the function minimum cost. Now what I'll do is, first I have to calculate prefix sums for efficient range sum computation. Range. Now, after this, what I'll do for this is initializing the DP. Initialize DP. Next one, track cost. Current accumulated cost. I'll just write as current cost, which is the current accumulated cost. Now, after this, for I in range, length of nums minus 1, comma minus 1, which is for iterating from the end to beginning. Iterate from end to beginning. After that, there's a final, the formula which I said, basically calculating the min cost. Calculate the min cost by forming subarrays from index I to j, and this is our final minimum cost, min cost, which is stored in our DP of 0. I'm gonna run this code. So this works perfectly. Now I'm gonna submit this and check if it works for all the test cases. Thanks, Pujit. So, okay, there's submitted, actually just now I submitted. This is one of the most optimized codes. So yeah, it beats 98%, both the places 98.15%. So with this we have completed our third question. The last step is left, finding the space and time complexities. Now, anyone in the chat, what is gonna be the time complexity for this code? I'll pin the chat if anyone is gonna say. If anyone in the chat says what is gonna be the time complexity, I'm gonna pin it till the end of the stream. Okay guys, we'll go to the time complexity. For this, the time complexity, prefix sum calculation, it is gonna take O of n iterating for loop. This is basically iterate over loop, and we all know for iterating once over a loop it will be O of n. Now DP array initialization. DP initialization is gonna take again O of n. Now after that, the dynamic program DP the DP iteration. The DP iteration is gonna take, for the outer loop, it's gonna take O of n outer loop. Okay, wait, guys. O of n outer loop and O of n for the inner loop, which makes its total time complexity as O of n square. Now, we'll come to the total time complexity of the whole code. Time complexity, this Tc is equal to O of n plus O of, okay, I'm sorry, O of n plus O of n plus O of n square, which is equal to O of n square. So the time complexity is O of n square. Now moving on to the space complexity. Prefix sum, again, prefix sum will take O of n dp array, it will take O of n plus 1 space, which means it also takes O of n space complexity. So the total time complexity is O of n plus O of n, which will be reduced to O of n. Space complexity is equal to O of n. With this, we are going to complete our third question. Anyone has any doubts, you can ask in the chat, guys. So guys, we'll move to our fourth and the last question of the day. We already saw this question. Now it is a bit more twisted here. Maximize active section with trait 2. We are given with binary string s of length n, where 1 represents active section, 0 represents inactive section. You can perform at most one trait to maximize number of active sections in S. In a trait, you convert a contiguous block of ones that is surrounded by 0 to zeros. Afterward, contiguous block of 0 surrounded by 1 to 1. I already explained you this. Now here is the additional part. Additionally, you are given with a 2D array queries, where queries I is equal to Li, comma Ri, representing substring S of Li to Ri. For each query, determine the maximum possible ways of active sections in S after making the optimal trait on substring S of Li. Return an array answer, where answer I is the result for queries I. A substring, we all know what it is, contiguous non-empty sequence of characters. Now note, for each query, treat S Li to Ri as if it's augmented with a 1 at both ends, forming T is equal to 1 plus SL to Ri, Li to Ri plus 1. Augmented 1 does not contribute to the final count, we already checked it. And queries are independent of each other. There's one more condition they have given here. Okay guys, so now we'll see this question. A bit complicated question, yeah, but solvable. Our fourth and the final question. is the name of the question, guys. Maximum active section trait 2. Max active section with trade. Second question in that. Now I'm going to the question. First, the inclusion. What is our inclusion, guys? We know how the trade works. First, trade working. Conversions. I already told how conversions. First one, second one. The first one is 1 surrounded by 0 will be converted to 0. Then 0 which is surrounded by 1 will be converted to 1. After this, to solve it efficiently, what I'll do is augment substring with 1 at both ends to simulate the effect of surrounded blocks basically. And then for each query, here identify maximum, identify max benefit, identify max benefit from performing trade, performing trade. Second one is you will be using a concept called segment tree here. I'll explain what segment tree is later after I explain the intuition. To find efficient, we'll we'll be using segment tree to find effective range of queries. Efficient range of queries. Why we are going to do this? To find the max gain. To find the max gain from merging consecutive 0 block and 1 block, 0 and 1 blocks. So with this, now I'll explain what a segment tree is basically. Segment tree. It's a type of advanced data structure segment tree is a advanced data structure. We generally use segment tree for fast range queries and updates. For fast range queries and updates. For example, if we have an array 2, 5, 1, 4, 9, we'll just take this random array. if we use a segment tree, it can efficiently return the maximum range. If we use, for example, max 1 comma 4, so it will easily return us 9, the maximum value. So this is what we are this is what a segment tree. Now what I'm gonna do now is I'm gonna jump into approach. The first one is pre-processing. The first one is pre-processing, where I'll be writing everything in short, guys. Now first one is create zeros array. This will store start and end indexes of consecutive, start and end indices of consecutive zero blocks. Consecutive zero blocks. After this, what I'll do is build one more array. Sorry. Before building our array, one more step I forgot. We have to use grouping here. Use grouping map each index of string to the corresponding block of 0. Corresponding 0 block. Okay. After this, the third step, we'll build one more. Build an array cumulative ones, prefix sum. We'll be using prefix sum used at the we'll be using prefix sum to quickly count number of ones in substring, in any substring. After the segment tree initialization, here what I'll do, I'll construct segment tree from block pairs length. Block after that, in the second step, the segment tree will help us efficiently find the maximum mergeable block. Helps us find max merge mergeable block. After this, we'll go to our second step. In our second step, query execution. Query execution for each query li, ri will augment substring virtually by adding ones at both ends. At both ends. Hey, sorry guys. After this, in my second step, within for each query of li, ri, I'll compute base value. Compute base value. For this, I'll count the active sections, which is once using count active section using prefix sum array. Prefix sum array. We know what it is. CUMONES. After that, in our next step, what we'll do is calculate our maximum trade gain. Okay. We'll go to our last substep. Calculate max trade gain. For this, what I'll do, augment substring. Sorry guys. Perform range queries on segment tree. Perform range query on segment tree. This will give me largest mergeable block. Largest mergeable block. So after this, I'll try combining adjacent. Next, I'll try combining adjacent 0 and I'll try combining adjacent 0 blocks and trade them for 1. Now, once this is done, what I'll do is I'll check for both ends of substring for optimal trading or possibilities. Check both ends of substring for optimal trading possibilities. So once this is done, the last step is what? I'll store my answer, store max result, store my maximum result in my array answer, which is ANS. They have given in the question. So that's all, guys. Now what I'll do is I'll go to the code and we'll add commands for the code for better understanding. I already added a few code. This ones I'll just delete all of them. I'll put them again. Okay, I'll remove all this one commands I wrote. Now, first initializing my segment tree, class segment tree. This is my initializing my segment tree, and then update function. This is to update value at specific index. Specific index, and afterwards we have defined query function. Query the maximum value in range. Query the max value in range, and then comes our given what do you say, class solution, and the given function define max active section after trade. In that, what I'll do, I'll add I'll add a helper function, intersect helper function to intersect two ranges. After that, there's a where I have declared an array zeros. This is identify all consecutive zeros. Consecutive zeros are identified and store their ranges. And ranges stored. Now, I said we are using CUM ones for cumulative sum of cumulative ones. Cumulative sum of ones. First, we have to define our initial condition. If length of zeros is lesser than 1, it means no valid trade is possible. No valid trade. This is a basic condition. Now we have to build the segment tree block pair length. Build segment tree with block pair length, and then here we'll query the maximum block, query the maximum mergeable block, and then here will get the max gain, get max gain from our segment tree, and then we'll check for the trade possibilities. We'll check for trade possibilities, and after that this whole thing is checking for what all the if conditions here are checking for our trade possibilities, and then finally this is my max final answer. Max active section, or I'll just write it as final answer, or as max array I need, max result, or final result, final answer. Now I'm gonna run this code. This works perfectly for the given test cases. Now I'm gonna submit it and check if it works well for all the hidden test cases. And it works very well for all the given test cases. And this is not the most optimized solution. For the most optimized solution, we can use the ITO tools and all other little bit of math principles for this. Intersections and all those we can do and optimize it. But for this, we'll keep it for segment tree, which is very simple to implement. Now I'll go for time complexity, the last, for pre-processing. For pre-processing, we'll be counting the number of zeros, counting the number of, sorry, constructing zeros, the zeros, and grouping. Both of this will take me O of n. Then cumulative sum of ones, CUM ones, will again take O of n. We'll go ahead. After that, segment tree will take construction of segment tree. Construction of segment tree is again gonna take O of n. Now in query execution, for query, each query, range query in segment tree, for each query, the range query in segment tree, it's gonna use O of log n time, and then comes the overall for Q queries. For overall Q queries, it will take O of Q into log n. So what is gonna be my total time complexity is here? My total time complexity is gonna be O of n plus q into log n. This is gonna be my final time complexity, space complexity. Now what is gonna be my space complexity? We checked already the arrays which we are taking, zeros, groupings, then segment tree, everything in this uses O of n space, which leads to the overall space complexity as O of n. So, with this, we are gonna end today's live. Chat. Anyone has any doubts? If there are any doubts, I'm gonna explain. Or else, with this, we are gonna end today's live stream. So, chat. Thank you everyone for whoever joined. Thanks for some good comments in the comment section. Mithun, Pujat, Uday, and Procoder. Thank you for your responses. I hope it was a good and informative session. Probably I'll be streaming tomorrow morning. Until then, have a good night. Thank you one and all who joined. Good night, guys, and bye.